Hi everyone, and welcome back to Newegg TV. My name's Paul, and we have a special video for you today with a special guest. It's JJ from ASUS. He said he would be back, and he is back. Welcome, JJ.
Thank you very much. Appreciate you guys for having me back.
All right. Today, what we're going to talk about is ASUS video cards. We're going to talk about ASUS video card technology in general, some of the special things that ASUS does when they're creating their video cards, and more specifically, we have a few examples here. These are all NVIDIA-based video cards. We have a GTX 560 Ti, GTX 570, and GTX 580. And JD is going to share a ton of information with us about these cards. So without further introduction, let's get right into it and start off with the GTX 560 Ti.
Yeah, definitely. I think that prior to diving into actually the lineup that we have it here is that, first and foremost, I guess we want to cover some of the key elements in terms of what we're introducing in our non-reference products. And to clarify for our users, when we discuss non-reference, that means the stage after the initial launch of the GPUs as they're released, right? Because we've, of course, seen 580, 570, even 560 parts, but the reference designs look quite a bit different, right? So our perspective is that when we're coming to the market and we're producing a non-reference part is how can we produce something that hopefully is going to be more reliable, maybe is going to have superior performance, and performance also has different metrics, right? We could be talking about performance relative to temperatures, performance relative to clock speeds, the longevity of the card, a lot of different variables, right, that come into play, and then other characteristics in terms of us, just how can we add, kind of our innovation into the card when we're designing it. So what we have here is our DC2 or DirectCU II lineup, and it's very easy to understand what we're talking about when we talk about DirectCU. So when we look at one of these cards, as an example, as you noted here with the 560 Ti, is that it's, of course, as you see, just like the rest of these cards, there's two fans. We originally launched DirectCU, which means direct copper, so as we're using heat pipe technology just like you have in a heatsink for a CPU heatsink, and that's generally very visible. If you kind of take a look right here, you can see the copper heat pipes as they're coming through the actual fins and the radiator right here, and then they go through, of course, to the GPU heatsink as well. But when you're looking at the DirectCU II, you're going to have the two fans. That denotes the two portion. And for our other lineup, which generally are going to be cards that don't have as high of a TDP, so they don't have as much of a heat output, those are going to fall under the DC1 lineup. So it's just going to be called DirectCU. So that's the distinction point between DC2 and DC1. In addition to that, there's also some other designs that we've done in terms of changing some of the heatsink assembly in terms of it being a DC2 part. So that kind of gives you a little bit of clarification regarding, when you take a look at our lineup, what that DC2 actually means. So two fans and then their direct copper heat pipe technology. Okay. Okay. Going over, I guess now, as you noted, in terms of the GPU lineup, what we're looking at here are base NVIDIA cards, but specific to the technologies that we're going to be discussing, whether it's the DC2, Superalloy Power, some of our preventative technology designs that we put on the card, it's going to be applicable to a really wide range of our product, whether it's AMD or it's NVIDIA. So there's no changes in that regard.
All right, JJ, so as you said, you guys have a non-reference design here. So as opposed to the specifications that NVIDIA has set up, these are all pretty much ground up, you said?
Yeah, they're built entirely from the ground up. What we do is we take back the feedback of both media and the user community as far as what they're asking for. Maybe they want the card to be quieter under game load. Maybe they want better temperature performance. Maybe they want to have a Vrm heatsink because they're going to be overclocking the card further, and they want to be able to have better reliability as they increase the voltages. So when we're doing the non-reference designs, we're really collecting a lot of feedback from our users to find out what we can do to improve in the card design.
All right, and you have gone ahead and removed our 4 mounting screws from this particular card here. Again, this is the 560 Ti. I just like the fact that you only had to remove 4 screws to remove this entire cooling solution here. Yeah. But did you want to talk a little bit more detailed about the changes you guys have made?
Yeah, definitely. And actually, you did bring up a good point. In terms of the actual 4 mounting screws, that's even actually part of our inherent design concept when we're working at doing our non-reference product, is we're trying to make it easy and accessible for the user in terms of working with our GPUs. We know that when we're talking about enthusiast class parts like, a 560 and above, or even if it was an AMD part, the user wants to be able to service the part, whether it is that they want to be able, after a year, go in, clean it up, maybe remove dust, debris, dander that might be filled in within the heatsink assembly. Maybe they want to reapply their own TIM, their own thermal compound. We want to make it easy and practical for them. Sometimes the reference solutions can have sometimes, 8, 10, 12 sometimes even 15 screws, and sometimes they're different threads, different sizes. So pretty much as a hallmark on all of our cards, generally for the DC2 lineup, you're usually just going to have 4 screws that you're going to be able to just remove and to go ahead and then be able to actually take apart the heatsink assembly from the actual PCB. So here we can actually see that we actually have the DC2 heatsink, and we can see that here we have actually the 3 copper heat pipes that are directly exposed, so making contact with the actual GPU itself. So that's what's very effective at allowing us to dissipate the heat, and then from there, of course, it traverses and goes into the actual radiator, and then from there, of course, we have the DC2 portion, so we have the 2 fans that are helping to actually create the active cooling in place. And you know, we do a lot of work in terms of tuning what's called the fan gradient or the fan ramp policy. And that's very important because the user doesn't necessarily always want to have like kind of this abrupt adjustment from going from, let's say, idle desktop where it's really quiet, generally inaudible, to then going to a gaming load and they hear a large rev up of the fan, right? We want to try to make sure that the gradient is effective at maintaining thermal performance and controlling that, but also at the same time not necessarily being loud, you know, very large, loud and obnoxious. So you know, that's a key tenet in terms of a lot of the feedback that we collected for DC2 was about making sure that the cards always maintain a very quiet level of operation, but are also very efficient at dissipating the heat. So that gives us some kind of perspective in terms of actually what DC or direct copper cooling is about. But when we're taking a look at the card itself doesn't sometimes always get a lot of showcasing, but there's a lot of non-reference elements that we bring to the table when we're actually taking a look at this card. Specifically here we have this 560 Ti. So one of the first and most important ones for us is, you know, in the past, in our motherboard conversations, we discussed power delivery and how that's always been a very important initiative for us, right? We introduced digital power delivery on motherboards, and that was a really big deal. We were talking about increasing the efficiency, the reliability, and the quality of power delivery. And we're making a similar transition on GPUs, and this is called Superalloy Power. So we have a very big commitment that across the majority of all our graphics card range, we're actually going to be having what's called Superalloy Power implementation. And you can actually see right here on this choke itself, it actually says SAP to denote it's actually a superalloy choke. And as a default tenet of all generally DC2 cards, you're going to always have superalloy power implemented on them. And that's going to be comprised of a superalloyed choke, a superalloyed capacitor, and then superalloyed MOSFETs. And the MOSFETs are generally underneath this portion, which we actually have a Vrm heatsink, so you can't see them right off the bat. But that in itself is also another little detail in terms of what we do. Not all vendors take it upon themselves to actually put on a Vrm heatsink. And that's an area that definitely, as you go ahead and you overclock the card, you're going to get more voltages going through as you increase to get higher frequencies, but you're going to be producing more heat, and therefore you're going to be increasing the potential that either you could maybe have burning that can occur to the PCB or to those internal components, or you could lead to a decrease in system stability as you overclock. So that little portion helps to also ensure better reliability and overall better component temperatures. So when we're looking at the rest of the card, you know, there's a couple of other little things that we're doing as well. There's small details, but they're details that we pride ourselves on in terms of helping to produce a more reliable card. So when we take a look here at the GPU, you can actually see here these like little white cornered notches.
Okay.
And these white cornered notches actually indicate that we have an actual technology in play that's called GPU guard. It's a special glue bonding process that it works actually in combination with actually another portion of GPU guard, which is this kind of brace mechanism that we put on a lot of the cards that have a non-reference cooler. Now, the main reason why we put brace as well as GPU guard onto the cards is that as you add more weight, when you use generally a non-reference cooler, which is going to be larger, you're going to add more stress to the center package. And the reason why that's important to consider is as you add more stress, you're adding torsion. So you're getting flexing. And flexing on PCB is never good because there's a whole bunch of little traces, right, that are all flowing from these parts of the card into the GPU. And those traces help to communicate information, right? And if you have too much torsion in those traces, you can break down their ability to communicate effectively, and that ultimately translates into a user maybe having a card that fails over time, maybe the game kind of drops in and out, overclocking isn't as reliable. On top of that, even without necessarily having that, let's say, added weight causing the torsion, a GPU goes through normal heat and cooling cycles. right? Because you're not always playing a game 24 hours a day. I mean, I guess you could, right? But
you can leave it on if you want.
It's probably not the healthiest thing to do, right? So when you're, of course, you're not gaming, the card's running significantly cooler, but when you're gaming, it's significantly hotter, right? And what happens is that cooling and heating cycle also expands and contracts the traces on a very minor level. And over the years, that can also cause degradation. So this GPU bonding process also helps to reinsure and give you better rigidity. And we'll definitely be giving you guys some information that you guys can release to your community to help reinforce so they can understand kind of what that's actually doing in the long term to help improve the reliability of the card. And that's an exclusive process to us. So while that's not necessarily part of Superalloy Power or even DirectCU II, it's something that users can have confidence in when they're buying our graphics cards. That we're kind of thinking about the long-term lifespan of the product.
The technology here, both for the VRMs as well as the GPU bonding you're mentioning, is that in place over the entire line of ASUS cards?
Generally, I would say all the mainstream enthusiast class parts and above. For SAP, this is a really big, important initiative for us. So because these chokes actually use a special kind of metallurgic process, a normal, let's say, choke, if you've ever seen it exposed, right, there's a toroidal dial on the inside. We're actually making this out of an alloy material, and it's all one solid block. It's almost like concrete. So it allows us to be much more efficient at power delivery. It produces lower operating temperatures, and it has a lot of other benefits. And all those components are made through this very extreme temperature compression process that we call, like I said, Superalloy Power. And that goes across pretty much cards that go down all the way to like a GT 440 class part. So even very entry-level GPUs are going to be using this higher grade of power delivery because it's important for us to not have it just be on the higher end crop of cards. We want it to be accessible to pretty much anybody that's buying an ASUS graphics card. So that's available across the board.
And for the end users out there, that's going to ultimately lead to greater efficiency, greater reliability, stability, long-term especially, and then also enhanced overclocking.
Yeah, definitely. I mean, even there's some certain benefits in terms of the adjustments that we make to the MOSFETs and to the capacitors actually increase the amount of core voltage that they can supply to the VRM as well. So we're also increasing the actual ranges of what these parts actually can operate at because of that superalloyed process. So across the board, you're getting a definite plus. Now, in addition to, as we noted here, we have the GPU guard, the SAP, you know, the bracing mechanism, the VRM heatsinks. We have some other little small detailing as well. We actually have these two circuits, and these actually are special fuse circuits. Now, in most systems, users should generally hopefully have some form of surge protection in play. And even higher quality power supplies on the market usually have some type of overcurrent or overvoltage protection built into them. But sometimes they don't work as they should, or maybe their surge protector is faulty. It's no longer operating the way it should. Video cards are one of the most susceptible to brownouts, surges, spikes, or sags, different things like that. So what this actually does is it's a mechanism that's built in, that's a fail-safe, that if that line comes in and one of the other stopgaps doesn't work effectively, when it hits the card, it will hit this fuse protection mechanism circuit. It'll absorb that so that it doesn't end up going directly to the VRM or to the GPU and killing the card. So it's another secondary measure at how we're helping to help extend the reliability and the operating lifespan of the product as well.
An extra line of protection, especially if you like to game in an electrical storm.
Yeah, well, I mean, you know, I mean, it's one of those things that definitely across the country, I mean, I think everybody agrees that, you know, sometimes you go to a friend's house, you might be going to a LAN party, and, you know, you never know necessarily what's going to be the quality of, you know, the electrical grid or the implementation that you might be gaming in, right, in terms of that house or in that environment. Now, going back to the actual heatsink assembly and the fan assembly, we're also doing something special with the fans here. These fans actually use a special double-sealed housing internally. And this actually housing is called our dust-proof fan design. And what this means is, of course, that it's not like that the fan will never collect dust. But inside of the actual hub assembly, if we were to go ahead and we remove the fan and we were to show somebody the inside, right, there's ball bearings inside there. And there's a housing that, you know, of course, rotates as the fan spins. The problem is that as you have your graphics card inside of a system, over time, dust, debris, dander, things like that collect and they build up. And when they get inside that hub assembly, all of a sudden, the hub assembly starts to rotate less, right? Eventually to the point that either it stops or it doesn't work the way it's supposed to.
It can get noisy too.
Yeah, it can also affect the actual pitch of the actual card, and that can cause it to get whiny or change kind of its audible characteristics. So we double seal that, so essentially it limits any type of dust, debris, dander from getting inside the actual hub assembly. Now, it doesn't mean that, of course, that the hub assembly still might not potentially fail. You know, I mean, just like any mechanical design, there's always going to be the possibility of a part actually failing, but it's another additional mechanism that we're putting in play. I'd still definitely always advise that users, you know, every couple of months go in there, you know, can to compressed air and a duster and you know, clean off, you know, their heatsink and make sure that everything is working as smoothly as possible. But, you know, for people that aren't consciously thinking about it, we have thought about how we can make this, you know, more reliable in terms of its operation. So that kind of gives you a little bit of a breakdown perspective at some of the key technologies that actually are applicable across the entire range. And you're going to have those consistently on any pretty much SAP DirectCU II graphics card, whether it's this 560, this 570, or this 580. As we touch on some of the other cards, we're going to maybe be increasing certain other elements and taking it further. In terms of the SAP, we might even have more items that fall under the Superalloy Power, which actually even this card does, for instance. We have on the back here this, what some people refer to as a POS cap. We actually refer to it as a superalloy cap because it actually goes through our superalloy process development. But we're really the only vendor that's doing it. Some other vendors have started to kind of copy us in terms of adding some type of they originally referred to as super ML capacitors or now prodigalizers to the GPU. But really what's key in terms of the implementation when you apply a higher capacitance capacitor to the actual GPU is proximity to the actual GPU. It's all about effectiveness in terms of communicating over a distance, right? Just like anything, the further away that I put something, it becomes much less efficient at being able to actually be able to supply power. So when we provide our increase capacitor to the actual GPU, we always do what's called back-to-back placement. It's the most complex and the most expensive to implement, hence why a lot of other companies don't do it, and they'll sprinkle them in all kinds of other places on the graphics card. But really, if you're doing your job right, you don't need 5 or 6. You really should just need maybe 1 directly on the back of the GPU where it's going to have immediate access to it when it's really starting to be pushed. Now, for the normal users, right, this card's only clocked at like 830 megahertz. It's not going to be a key issue at that frequency. But if they want to start ramping the card higher, you know, at that 950, 975, 1 gigahertz, maybe even, you know, 1050, you're going to start to be, of course, drawing more current. There's more voltage coming into play, and you need more capacitance, so the ability to be able to provide current when it hits it hard under that load, so that the power delivery is there. So that helps improve the overclocking headroom. So you can see, once again, to reiterate at the point here, we have the POS cap or the SAP cap, and where is it? It's directly behind the GPU. Can't
really get much closer than that.
Yep, that's as good as it gets. So that kind of gives you a little bit of an overall perspective in terms of what we're doing specific, of course, to this card, the GTX 560 Ti, which, you know, it's a great part, you know, for anybody that's looking to do 1680 by 1050 or even 1080p gaming. You know, you can even do AA and things along those lines, and of course overclocking even takes it further. But that kind of gives you a little bit of a recap on the 560.
All right, so moving right along to the 570, and first thing that I noticed for this card as compared to the 560, we have a triple slot cooling solution.
Yeah, it's considerably bigger, right? When we look at this, this is just a beast of a card, right? You know, we spent actually a lot of time doing a lot of polling within the actual forum community, our retail partners like you guys, actually looking back at the feedback that the users provide to you, as well as actually discussing with media and going to a lot of gaming events, QuakeCon, BlizzCon, PAX, LANFest, and we spent about 14 to 16 months collecting this feedback. And the biggest piece of feedback that we got from gamers is not only do we want really low temperatures, but even more than that, as a kind of general tenet, we want our cards to be quiet when we're gaming. We don't want these large kind of, you know, crazy vacuum cleaner kind of cards, right?
Helps with the immersiveness from the game. You don't hear your computer.
Yeah, so, you know, it's just kind of just the general expectation. Everything has kind of improved in terms of being able to give us a high level of performance, but be quiet. You know, we've got really good CPU coolers that can still be overclocked and still give you, you know, good temperatures, but also still be quiet in terms of their operation. And while GPUs are a lot more complicated than that and even produce a lot more heat, users are looking for that same level of performance. So what we did is we were looking for a design that was really able to give us a really high level of TDP dissipation, so a high lot of wattage dissipation, but also be able to really maintain a low noise floor. And that came through the actual advent of DirectCU II, and on these higher end parts, this triple slot design, where we can go with a really large 5 heat pipe heatsink assembly with dual radiators, and then these large fans with very large CFM, but because of course they're a larger diameter, they're able to rotate at a slower speed, and hence the slower the speed, the quieter the card. And even under very heavy gaming loads, so when you're talking about stuff like a Crysis 2 with the DX11 patch and all the AA and tessellation, all that stuff cranked up, you know, you're talking about that these fans generally aren't going to be exceeding 30% in terms of their rotating operation. And that's going to leave you with a card that's very quiet. In most instances, I would say that users are generally going to have almost an inaudible experience when working with the DC2 class part. And our statistics also show that the majority of users, while I think everybody wants to be able to run 2-way or 3-way in their systems, most people are only running a single graphics card. So the triple slot design isn't generally impacting them, and they get that benefit of having a really quiet card, but it also giving you really good temperatures.
And I would also note that a lot of motherboard manufacturers, ASUS in particular, I know you guys have done a lot with the triple spacing of SLI slots, or I should say PCI Express slots. So even with a triple slot design like this, you can still set up 2-card SLI.
Yeah, we're very,
you get that type of motherboard.
You nailed on the head. You know, we've discussed that in the past on our motherboard previews, where we're very adamant that we try to maximize the spacing potential on the board, so that if users go ahead and have that type of you know, triple slot configuration, that they have the accessibility to be able to run the 2 cards and still have space within them. Of course, you know, that's not going to be on all boards because of the triple slot, but you know, definitely on any of our boards, like on the DC2 class, more entry-level parts like this 560, that's going to be almost every single board dual slot spacing. You'll still have a space in the center, but only some of the boards will allow for still a space with a triple slot card. But speaking here specifically to the 570, as you've been looking at it, one of the really key things that we can see here is that, one, we've gone to a larger diameter heat pipe configuration than the heat pipe configuration that we have on the 560, and there's actually 5 heat pipes. And in addition to that, you can also see that we actually have a full sustainer bracket across the entire back end of the card. And this is to help make up for the additional weight and ensure a solid level of rigidity and stability when it goes inside the chassis, right? Because nobody wants to put in a card like this where you got a huge amount of performance but also feel like it's going to be drooping or impacting, right? And that's key because not a lot of vendors are always taking this kind of design consideration into play. You'll see some other vendors that maybe might do a triple slot and they won't have a sustainer or they won't have a brace mechanism, and the card will actually droop, especially towards the back end, and you get this bad type of torsion that will help stress the GPU, and it's not good. So, you know, this is just us helping to extend that we're taking into consideration all aspects of the card design. Now, when we're talking specific here to the 570, just as we discussed on the 560, you remember we were talking about that back-to-back concept design, right, for the POS cap or SAP cap. We now have here the next evolution of a SAP cap when we go to a Pro Digitalizer, which is a much more advanced type of capacitor. Still the same concept. It has very large capacitance, so it's about storing the current to be able to drive to the CPU, but it does it even more efficiently and with a higher level than what the SAP cap has to offer. It's still part of our SAP initiative in terms of giving that higher level of power delivery to the board, and you can still see we're doing the key things in terms of 4 easy screws to be able to remove this whole thing. But the key aspect is that we're talking directly behind the actual GPU to ensure the best power delivery. The other design tenets in terms of what we discussed on the 560 series, where we're talking about all the protective designs, the SAP, the Vrm Heatsinks, all that is still the same on the card. And lastly, we will say that we do try to also help to maximize the usability of the card in this larger form factor. So you can see that we're also giving a little bit more connectivity because, of course, we're going with a larger card. Generally, with a standard card, you're usually only getting 2 outputs. But here, outside of the 2 DVI ports, we're giving you the full HDMI and the full display port. Sometimes some of the other vendors are just giving you a mini HDMI or a mini DP, and that sometimes is a little bit trickier to work with because the guys have to kind of find an adapter to be able to connect it to to their monitor, right? So that kind of gives us a little bit of an overview relative to the 570, which, you know, it's a fantastic enthusiast grade part, really focused at kind of the next level up. People that are really looking at 1080p based gaming or even larger resolutions, right, when they're going to like 2560, right? You know, the next card up in the chain is definitely going to be looking towards that end.
And that would be the GTX 580, if
Yep.
I'm not mistaken. Here we have the big beast, the top-end Vrm chip as far as the GPU goes.
Yep.
And again, we have the triple slot cooling solution. And for folks looking for, I'm going to say 1080 gaming with a lot more eye candy turned on, and aliasing, tessellation, that sort of thing. Or if you're going for that higher resolution you mentioned, the 2560, or possibly using multiple monitors, 2 or 3 monitors, to do multi-monitor gaming, which is pretty awesome.
Yeah, that's going to be key. I mean, when you talk about 3D gaming, because of course, generally it's going to be going to reduce your primary frame rate by about half. It's going to be key that you have a high horsepower GPU, whether it's like a 570 or a 580. And you're definitely right. If you want to go to like NVIDIA 3D Vision Surround, then putting 2 of these guys in SLI is going to be able to definitely equip that type of driving performance for those real cutting edge titles that have the ability to be, you know, be expansive and detailed like that. In terms of the card itself, you know, it's almost going to look like a twin when you're comparing it to the 570 because we did the design right here. So most of the same tenets are already here. We're still doing the same type of brace design. We've got the predigitalizer in play, the brace, same type of connectivity, and of course we have the DC2 implementation in terms of having the large CFM but low rotation based fans, and we still have the complex heatsink and fan assembly on here. So that pretty much covers us for kind of an initial overview relative to DirectCU II and how it fits into kind of the VGA landscape that we have, short of our RG cards, which of course take it even to a higher level.
And before we close up here, we wanted to take a closer look at the ASUS GPU Tweak software, which you can use for video card monitoring as well as overclocking.
Yep, that's right. Let's go ahead and take a look here actually at the software. I've got to have it hit in here on the screen. This is a brand new piece of software that we're releasing soon, and it's replacing our Gamer OSD and Smart Software utilities. What we see here right now on the screen is actually our brand new GPU Tweak utility. It recently launched with our GTX 580 Matrix graphics card, but it's going to be a brand new piece of software that we're opening up to be available for actually our entire range of graphics cards, as well as actually even competitors' products. The one differentiation between running it on our card as opposed to a competitor's product will be that certain functions, such as maybe memory timings, the special live update option for enabling a BIOS update, or other specialized functions might only be available on ASUS graphics cards. Now that doesn't mean that the core functionality like overclocking and monitoring and voltage controls still won't work on a competitor's product, but you're not going to get the maximum experience out of the software unless it's run on our card. But here you can actually see that it has a 3-panel interface. It's very clean. We've worked with Tech PowerUp to actually include the very popular GPU-Z for information. We have the center console, which allows us to have all the adjustments in regards to frequencies and voltages and fan speed adjustment. We have a live update tab, which actually will allow us to do real-time checks for the latest vBIOS in the event that we make an adjustment relative to performance or fan controls. Settings to, of course, allow you to make adjustments, whether it's to the monitoring tabs, how it starts up, recording functionality for either screen grabbing or for video capture, and then, of course, we have the actual monitoring screen itself. So this is definitely something that we're going to be putting a big focus on. It's going to be rolling out on our entire series of graphics cards, and look out soon for an announcement as to where you can go ahead and download the software. And that is going to wrap it up for today's video. We hope you guys have learned a little bit more about the ASUS line of DirectCU II video cards here. Also about some of the special attention to detail that ASUS pays when they're designing these cards from the ground up. If you didn't notice, we have a couple Republic of Gamers ROG, the red box cards here, also from ASUS. We're going to be following up with another video specifically about those cards. We got the Mars 2 as well as the Matrix GTX 580. But that's for the next video, so stay tuned. I would like to say a big thank you to JJ for stopping by and sharing some information with us. Thank you as always for having me. All right, and thank you all for watching out there, of course. If you'd like to see more videos on tech products and that sort of thing, please head over to our Newegg YouTube channel, and don't forget to subscribe. Thanks a lot for watching, and we'll see you all next time on Newegg TV.